Okay, we have question number 7D from October-November 2017, paper 4, variant 3. This is the last part of this graphs of functions question, and I've been requested to answer this question about completing the square. Again, well, actually it's not completing the square only. There's other ways of doing it, but I'll show you both ways, okay? Because actually for this particular question, I personally feel that the other way, apart from completing the square, is probably a bit easier. So I'm going to show you both ways, and you can do whichever way you're comfortable with. Okay. So the way completing the square method, okay, completing the square method would be done as follows. Okay, would be done as follows. You would basically make sure that it first says 1x squared. So you start off with y equals 2x squared plus 5x minus 3. Okay, now what we want to do is we don't want to have a 2 in front of the x squared. So what we got to do is we got to take out this 2 as a common, well, as a factor, not as a common factor, because there's not a common factor. I'll take this 2 out as a factor, and I'll be left here with x squared. Now what do I do with this 5x part? Well, it's going to become 5 over 2. Why? Because 2 times 5 over 2 gives me 5. Okay, I'm going to have the x there as well. Now what I'm going to do, which some people don't do, is I'm going to close this bracket here. So I'm only dealing with these two terms, and then I'll just put minus 3 at the end. It's just hanging on at the end of the expression. Okay, so I'm just dealing with these two terms because I want to complete the square I'm worried about the x terms and x squared term. Now what I've got to do is I've got to now continue complete the square. Why did I do this? Because when we complete the square we should have 1x squared. We can't have any other number here. Alright, so I'm going to have 2 times bracket x squared plus, why did I put 5 over 2? Because that's what I have to multiply by 2 to give me 5. Because that has to be the same. These two expressions have to be exactly the same. I'm just rearranging it or rewriting it in a different form. They must be the same. Alright, now what I can do is I can write a square bracket. So what I'm going to I have to be very careful here, because this 2 is going to multiply whatever inside this bracket becomes. So to complete the square for something like this, you write the x term without the square, you write the sign that comes next, and you take this number, okay, the coefficient of x, and you divide it by 2. Now 5 over 2 divided by 2 is the same as 5 over 2 times a half. So it becomes 5 over 4. So this is like 5 over 4. And then you have to write the square. Now, if I expand this bracket here, if I square this bracket here, I'll get x squared plus 5 over 4x plus 5 over 4x, which gives me 5 over 2x. But then I'll have plus 25 over 16. I don't want to have 25 over 16, so I got to take away that 25 over 16. So you always take away the square of what comes in this part here. Alright, now because I close my bracket here, I must close this bracket here, because that 2 is taken out as a factor from this bracket, and it's not been taken out from the minus 3. So then I'll write minus 3 at the end. Now these two lines are exactly the same. They're exactly the same. Right? And now I can continue. I'm going to multiply 2 with both of these terms. So I'll have 2 times x plus 5 over 4 squared minus, now 25 over 16 times 2, you get 25 over 8. And I got my minus 3. So you notice I multiply the 2 by these two terms and not the minus 3, because I had closed a bracket there. I didn't include the minus 3 when I took out 2 as a factor, you could say in inverted commas. Now you got y equals 2 times x plus 5 over 4 squared. Now 25 minus 25 over 8. Now 3 is the same as 24 over 8, isn't it? Make them the same denominator. So minus 25 minus 24 is minus 49 over 8. And there we have completed the square form for this expression. So it can be written in this form here. 2 times x plus a squared plus b. Well, the a must be 5 over 4. And the b must be negative 49 over 8. Because it says here plus b. If that said minus b, then b would be 49 over 8. Okay, depends how they express this. That's one way. That's what I would consider a more complicated way in this particular case, because we have a number outside, we have a number in front of the x squared. If you didn't have that in the beginning, it would probably been easier to complete the square. The other method of solving this problem is to actually do the reverse. So you're going to expand this to make it look like that. What we did in part one is we made this look like that. We made the 2x squared plus 5x minus 3 look in the form of something, squared brackets, and then we compared. Now I'm going to make the square bracket part, I'm going to expand and make it look like this, and then I'm going to compare them and see how to deal with this. So I'm going to take this y equals, we're going to have 2 times, and this is like x plus a times x plus a. Okay? Plus b. So if I expand this, I'll have 2 times, let me expand what's in the bracket first. You have x squared plus ax plus another ax, which is plus 2ax, 2ax plus a squared plus b. Remember, it's all multiplied by 2. Got this 2 here, okay? Sorry, what am I doing? Yeah. And then I've got my plus b at the, sorry, what am I doing? Forget that plus b. It's 2 times x plus a squared. Sorry about that. That's x squared plus 2ax plus a. Then you've got your plus b at the end without, of course, the b is not multiplied by the 2. All right, so now you're going to expand this. You'll have 2x squared plus 2ax plus 2a plus 2a squared plus b. Okay, so you have 2x squared plus 4ax. Sorry about that. Let me just cross that out. So you have, 2x squared plus 4ax plus 2a squared, and then you've got your plus b at the end. Now if I compare this with the original, so I'll write this down, I'll say 2x squared plus 5x minus 3 is equal to 2x squared plus 4ax plus 2a squared b. If I compare the x squareds, got 2 and 2, that's fine. If I compare the x's, alright, I know that my 5 must be the same as 4a. Okay, the 5 must be the same as 4a. If I compare the x's, the 5 has to be the same as 4a, right? Because if these are the same, then they have the same coefficient, so that 4a must be 5. If 4a equals 5, then a is equal to 5 over 4. Okay, which is exactly what we got from completing the square. And then once we know that, I know the minus 3 must be the same as the constant here, which is 2a squared plus b. That's a plus here. So you got negative 3 is equal to 2a squared plus b. I think my computer needs a restart. It's getting a bit messed up. Anyway, so you got negative 3 equals, now we know what a is. A is 5 over 4. So this is 2 times, now a squared is going to be 25 over 16 plus b. Now 25 over 16 times 2 is 25 over 8. So we're left with b is equal to exactly this. It's equal to minus 3 minus 25 over 8. Does that look familiar? Yes, it does. Minus 25, 8 minus 3 gives you exactly the same answer as that. It's the same thing. Let me just make that a bit neater. My computer is a bit messed up right now. Excuse me. So you got b will be minus 3 minus 25 over 8, which is exactly the same as what we got before, which gives you minus 49 over 8. So there we have the answer for this question done in 2 different ways. One using completing the square, and one by expanding, doing the reverse, like you're expanding what they gave us and make it look like, and then compare the coefficients of x squared, x, and the constant to then find what a and b are. Okay, that's the answer to that question done.